So now we are going to solve an example on Ohm law. Okay. So this example says that we a cylindrical resistance of cross-sectional area A and the length of the resistor is L. Okay, and is made from the conductivity from the material having conductivity sigma. Okay, now it says that the potential difference between this end and this end is V, and the potential at this end is constant. Okay, so now we have to calculate what current flows. The required thing is what current flows to this resistor. So solution to this problem can be found in the Ohm's law, okay, which says that J is equal to sigma and E. Now as we know that E is constant throughout the conductor, okay, so and we also know the current density, okay, so when E is constant we can use this relation that E is equal to V divided by L, which we calculate from V is equal to E dot L. Okay, so we will divide L on both sides, so we will find E. Okay, this is equation 1. Okay, and now J is equal to I by A, the cross-sectional area, and we name it as equation 2. Okay, so now put equation 1 and 2 in the Ohm's law. Okay, so this will be like I divided by A equals to sigma into V divided by L. Okay, now multiply by A both sides, multiply A here and multiply by A here. This will cancel out, so I will be equals to I is equal to sigma A divided by L. Okay, and this multiply by V. So here if we compare this to the equation I is equal to V divided by R, so this value is equal to the resistance. Okay, so I is equal to sigma A divided by L and V, so I equals to V divided by L divided by sigma into A, and now this value is R, so which is V divided by R. Okay, so I is equal to V divided by R. This much current flows through this resistor. Okay, we can say it this much current flows, but this is simply 1 divided by R, so we can use this relation and hence we can prove this relation in this way. Now let's have a look at the second example.